Hello, everyone. How are we doing today? That was really pathetic. How are we doing today? Awesome! All right, there we go. I have 4 slides for you here today. You've seen them. They're rotating. So this is entirely live demo. That means that at the end of this talk, I will also open source all of the code and the script for this. So check out my GitHub. I'll tweet out a link at the end. But this is a lot of terminal and a lot of text. I'm going to assume that you went to either or both of Jamie and Fletcher's talk. If you didn't, I'm going to quickly talk about Habitat, but at a very high level. So for those of you watching at home on the YouTube channel, stop. Go watch Jamie's talk. Go watch Fletcher's talk. Now come back here. Cool. So I'm going to stop this. I wasn't kidding. There were 4 slides. And let's go ahead and get started. Who's excited? All right, that was okay. All right, so is this a good font size for everyone? No? Okay, I can make it bigger. That's fine. Hi. Okay, so what I'm going to be doing today is I'm going to be using a demo application. And no Habitat, no Chef, no Terraform, no Packer, no anything. I want to show you what that application does. It's a Go binary. So I'm just going to go ahead and build that Go binary right now. And I run go build. And voila, I have a Go binary. And that Go binary is called HTTP echo. It's a really tiny, in-memory HTTP server that echoes what I give it. So I'm going to give it some text of like, hi. And it's going to start a server listening on a configurable port, 5678. And if I curl that port, localhost 5678, I get back that text. Okay, and I get a log message that says like, hey, you got that. So that's what we're dealing with here today. That was like no extra tooling. This is just a tiny little web server. This could be a really complex application like Rails or WordPress, but I wanted to limit the number of abstractions, so this is what we're working with here today. So in order to build this, I needed like a local Go development environment, and I have all that set up because I'm an engineer by trade, but you might not be a Go developer, or you might not need all of this, so let's jump into Habitat. So I'm going to stop this, ChefConf 01. Okay, so the very first thing I have is we're starting on a journey. So this HTTP echo server, this is going to be the next MySpace, and I'm Tom, here to guide you through the journey. So we have to start out somewhere, right? We have to start out with our tiny little application in order for it to be big and be the next big MySpace. But we need local development first. But for now, let's just pretend that I'm running some off-the-shelf MySpace solution where the static binary is already precompiled, and I just need my own config on top of that. And that's the first Habitat scenario I want to walk you through. So let me take a look at what I have here. Inside my directory, I have a Habitat folder, and inside that Habitat folder, I have basically 2 things, a plan file and a default.toml or toml, depending on how you pronounce it, and I have a hooks directory. So let's take a look at the plan first. So inside this Habitat plan, I have a number of configurable things in here. I'm specifying like my name, the package name, and where to download it from. What you should get out of this, the important part here, is this source on line 7. This is telling Habitat to go out to, in this case, GitHub releases, and download this precompiled tarball. So in advance, I've gone ahead and compiled this. So I don't need Go, I don't need Ruby or any nonsense. It's already compiled, a single static ELF binary with no dynamic dependencies. And then I'm using the shawsum on line 9 here just to guarantee that I get the right thing. So if for some reason the Wi-Fi craps out, or if I am subject to some minim attack, this will prevent that from happening. I'm adding the resulting thing to my bin, so this will make it available as an executable binary. And then I'm exporting and exposing port, and I'll show you what that is in a second. But if you remember when I started the service, it ran on port 5678. But I might want to run it on port 1234 or 67,123. And the binary lets me do that, and we can actually configure that via configuration file in Habitat. I also have a few things here, like the build step. And in the build step, you'll notice that it's really complex, return 0. Really, really tough stuff there. That's because by default, Habitat wants to build my package, but I'm using a precompiled binary in this example. So I just overwrite that and say, hey, don't worry about it, I already built it. And then in the install step here, I am simply moving that compiled binary into the path. Habitat automatically unarchives it for me. So you noticed above it was a tarball. Habitat will automatically unarchive it for me, put it in the source path, and I just need to move it into bin and give it executable permission. So what about that port thing? Well, if we take a look at the default.toml, you'll notice that there's two configuration options here. There's the port to bind the service to, and the text to render. And these are the default values. 5678 is the default value for the port, and text is hello ChefConf with an exclamation point at the end. So the last thing that I have to show you then is this run hook. The run hook is the thing that actually runs the program inside the supervisor. So this is the thing the supervisor is going to run. HTTP echo is already in the path as part of the do install step. And I'm telling it to listen on a particular port, which is from the configuration. And I'm telling it to render some text, which is coming from configuration. So those things between those curly braces there, the little squiggly lines, those are coming dynamically and being filled in by Habitat and the Habitat supervisor. So sys.ip is the current IP address. So I'm binding to the IP address of that instance. And config.port or cfg.port and config.text are coming from that default.toml file. And as you might imagine, since it's called default.toml, we're actually able to overwrite those things, which we'll get to in a little bit. But for now, let's just see what it looks like to run this thing under Habitat. So I'm going to go ahead and enter my studio. And implementation detail, this is going to like start a Docker thing and do some magic. Docker. And I'm going to build this binary. And build is a little bit of an overstatement here, because it's actually downloading a tarball, unzipping it, and putting it inside of a container. Done. That fast, took about 6 seconds. Really tough stuff here. And there's a bunch of output here, but it's not important. What's important is that you think about the high level. Is I had a pre-built binary on an archive service, in this case GitHub releases. I downloaded it, and now it's in a Habitat package. And we can run it. So I'm going to go ahead and run habsvc. I need my little cheat sheet here. Start. And it's called Seth Vargo /HTTP echo. And it says the supervisor is starting, and we can see that it's running by running sublog, or SL for short. We can see, OK, there's some output there, and great. There's the log line from my server. It says it's listening on sys.ip, which was interpolated to 1702, and it's running on port 5678 on the new line there. Thank you, line wrapping. There, now it's on the same line. So this is running, and we can curl this URL here, so we can actually copy this IP, and we can curl that, and we get hello ChefConf. And that came from that default.toml file. So that text was interpolated in that run hook. It's listening on the port and the IP that was configured. So let's go ahead and stop this service now. I'm done with it. We're moving on with a demo. So I'm going to go ahead and stop the HTTP echo service. That was pretty fast. So let's verify in the logs. OK, we got a stopping signal, but what is this? There's this kind of scary log line here. Unknown signal terminated. Well, and then it says that it shut it down. And I don't know about you, but Jamie Windsor and Fletcher told me that SV stands for supervisor, but I believe they named it after me, Seth Vargo. So every time you see SV, just know that that's actually named after me. So right now, notice that second to last log line there, error, that's coming from my application, my Go binary. Well, what's happening is after some research, I found out that Habitat sends term, T-E-R-M, as the signal to gracefully terminate an application. Well, my app doesn't respond to term. It responds to int in order to shut down gracefully, which is just another Unix signal like USR1 or quit or whatever. So I actually have to update my application, my Go binary, to also listen to term. Because since this is an HTTP server and it's going to be as popular as MySpace, I can't just be dropping connections all the time. So once we reach massive scale and we hit our critical mass, we need to be able to gracefully drain connections. And my code already does that. I already wrote the code to do that, but it only does that when it responds to the right signal. In this case, int, but Habitat's sending term. So let's go ahead and exit this studio. And when I exit the studio, everything's gone. So let's move on. And what I have to do now is in order to change this behavior, I'm going to have to compile from source. So we need to make a few changes to our plan. So again, you'll notice that I have that Habitat folder, but I also have a source directory. So I downloaded as much ahead of time in case the Wi-Fi was terrible. Inside this source directory, I have my actual Go source. So I have all the Go files in there are the important ones. We can actually remove some of these because I tested this earlier. source. OK, so we have 4 files in here, server, version, handlers. If you don't know Go, none of this actually matters. What matters is I need to change the signals that my application responds to. And I've done this ahead of time so that you don't have to watch me type. But down here in this section, I added this particular line of code, or in this case, half a line of code. So I said, in case I receive a sig term, also do a graceful shutdown. And you can see previously it was just sigint. So now when the Habitat supervisor sends term, my application will drain the connections and shut down. But this is source code, and let's just pretend that I don't have a Go environment ready to go. So how do I build this? Well, with Habitat, we can update our plan to remove all of that stuff for downloading it, because we already have the source code here. We don't need the tarball anymore. And instead, I'm adding a dependency on what's called core Go. So you'll see here, this is a package dependency on core Go. What this is going to do is it's going to build or bring down all the packages that I need to build this as a Go binary and run it in a Go environment. So that means we also need to fill in our do build step. So remember before, the do build step was just return 0, but now we're copying our source code into the cache and building. So same go build command as before. And then our do install step is exactly the same, no changes there. So we actually net lost 2 lines of code out of the plan file. We added 1 line of code to do build, but we removed 3 from the top. So we're actually net lost 2. So this is actually a smaller plan, but we're pulling in a whole Go context now. But the process, the workflow is still the same. And the hooks and everything haven't changed. So I'm going to go ahead and enter my studio. This is a different studio from before. Each time you enter the studio, it's different. You'll notice that it downloaded some stuff at the beginning. It downloaded curl. But when I run build, it's downloading the Go core. So that came from the package deps. And it downloads all the dependencies that the Go core needs, because we need those to be able to compile from source. And now it's going to start building our application. So it pulled everything down, and now it built the application. And this one took a little bit longer. This took about 20 seconds, because we had to compile the thing from source, and we had to download some extra external dependencies. But now we have the service, and we can start it again. So we can run hab svc start Seth Vargo http echo. It's running. We can run in the logs and see that it's running. There we go. It just started. We can curl it to make sure that it's running. So curl. Great. It's still running. And then the moment of truth is, did we compile the right thing? So I will hab svc stop. And we'll check the logs. And there we go. We got a note from our service that said received interrupt, and we got a graceful termination, which means my application gracefully exited, and it drained connections. So if it was under really high load, right, if we reach MySpace scale, and it was under really high load, my application would drain connections before it terminated. So we have a well-behaved application here. And to a certain extent, this also illustrates another point, which is Habitat's a really great tool, just like Docker and Rocket and all of these tools. But at the end of the day, there are certain things that are application responsibilities. This isn't something that Habitat can solve for you. If you have a server or a service, it should know how to drain connections when it receives a certain signal. That's just a property of like a well-behaved application. So let's move on to something a little bit more exciting. I don't know about you, but if we're going to be the next MySpace, we need more than one of these, right? Because it's Go and it can handle, but I don't think it can handle MySpace scale. So we need to do some dynamic scaling. We need to really be able to build this thing out. So let's check it out. So go up a directory to dynamic. And in here, I have the same source, the same Habitat directory, but there's a few differences inside this Habitat directory. The first is in the run hook. The run hook, solely for demonstration purposes, has added a new line. So instead of just rendering the config that comes from the default TOML file, it's also printing out its hostname, its IP, and the port that it's running on. And that'll become important because when we put this thing behind a load balancer, we want to actually be able to see that we're hitting different endpoints. Now, if this was a real application, you'd want it to behave the same. But for the purposes of the demo, we're kind of cheating here a little bit and trying to make it look as interactive as possible. That's the only real change here. Everything else is the same. So we'll go ahead and enter the studio. And we'll build this thing. Notice that this workflow is always the same. So I work at HashiCorp, and we're a workflow company, and we focus a lot on workflows. And this Habitat tool is also a workflow tool. I enter my studio. I run build. It doesn't matter if I'm running Ruby or Go or Python or PHP or COBOL. Like, it's the same workflow every single time. And I'm just talking to kill time while this compiles. Perfect. There we go. You can cut that from the stream. Great. Let's start one of these. One of these things. Where's my little? Yeah, here we go. So we'll start one of these things. Start Seth Vargo, HTTP echo. OK, this thing is running. Sublog. You're starting to get the hang of this, right? The thing is running. It's running on the right port. And this time, I'm going to grab this IP to my clipboard, because we're going to need it in a little bit. But now I want to apply a config change. So what I'm going to do is on my the thing here, I'm going to run habconfig apply. Then I give it the target group that I want, the target service group, which is just going to be HTTP echo.default. I give it a monotonically incrementing integer, which is just going to be 2 in this case. And I'm going to give it the thing that I want to change. And in this case, I want it to change the text. So I'm going to say, if you remember, the current text is hello ChefConf. So I'm going to change the text to say hello PuppetConf. Awkward. And we'll run the log command. You'll notice there's that hooks recompiled there at the bottom. And hopefully, if we curl the right port, 5, 6, 7, 8, we'll get hello PuppetConf. Well, shit. This is awkward. We should fix that. So we can go back, and as long as we use a higher monotonic incrementing integer, I can change this back. And if we curl, we're back to ChefConf. Pretty cool, right? I didn't have to restart the service. I didn't have to do any of that. And it's going to be even cooler when we put this thing behind a load balancer. So in order to run this at scale, the Habitat supervisor currently can't run multiple instances of the same package or same application. So I'm going to export this to Docker, which thankfully Habitat makes really easy for me. So I can just say hab package export Docker and the name that I want it to export as. And this is going to download all the stuff that it needs to export as a Docker container. And again, I'm going to attempt to talk my way through this, but it's Docker. So it's going to not only install all of those things, rebuild my package, but it's also then going to rely on the whole Docker build process. So in a second here, you should actually see the familiar Docker output. There, it just started. So we're sending the context to the Docker daemon. And here's your standard kind of iterating over the Docker file. Notice that I didn't write a Docker file. I didn't have to touch Docker. It just happened to be installed. And now I'm exporting a container. So I don't actually have to think about the whole Docker file process or any of that. And we're done. So now I have a Docker image on my local laptop. And I'm going to open a new tab to show you how this works. So what I'm going to do is I'm going to start one of these outside of the studio. And the way I do that is with the familiar Docker run command. And I'm going to run it in interactive mode just so you can see the logs, but it could start in a background process. And it's just going to be the name of the container. So here we go. Notice the familiar output, but this is running in Docker. And I'm on a Mac, so it's running in Docker for Mac. And notice that it's listening on 172.17.3. And that's the way that Docker's IP networking works. We already have something on .02. So now I want to start a second one of these. Well, how do I do that? In order to do that, I have to group them together into a peer or like a service ring. So I can't actually do that in this scenario. So what I'm going to do instead is start a new tab here. And I'm going to run the same command. But this time, I'm going to specify the -- peer flag. And I'm going to pass in the IP address of my already running container, which in this case is the 1703. And when I run this, it's going to start up the same, but you'll notice there's that hooks recompiled. And if you look above it, you see another hooks recompiled. That's your indication that those two services have found each other. And we can do this a third time. And I can join any one of the other IP addresses. So in this case, I have 2 of them joined together, but the way that the gossip protocol works under the hood is they all find each other. So all of these services are now gossiping. They're communicating with each other. And I'm going to clear all these screens here. But now I need a way to address them. So I have 3 of these things. There are 3 instances of them running. And a really common pattern is to put them behind a load balancer. That way traffic is kind of round-robin or some type of routing algorithm to all of these services, and we'll make that accessible to the users of our application on myspace.com or whatever our application is going to be. So the way I do that is by opening yet another new tab. And I'm going to start a Docker container, which is a Habitat service that I built ahead of time. This Habitat service is called Nginx LB. It's fully open source. It's on my GitHub. What it does is it accepts a series of binds and binds to a backend and automatically creates an Nginx load balancer based off of that. So I'm not going to go into super detail there. You're free to use it and look at it as you want, but it's just an implementation detail of this talk. So I'm going to go ahead and run that, again, in interactive mode so you can see the details there. But I'm also going to bind to port 80, and I'll show you why. Well, I'm going to bind to port 80 on my host and on the container. So it is Seth Vargo / Nginx LB. And then it needs a few things. It has to join the same peer group. So I'll have to pass in the -- peer flag, which was, 172.17.0.3. But then it also needs a -- bind argument. And this is the backend service to bind to that I want to route traffic to. And in this case, that's just HTTP echo.default. That's the backend service group. So I'm going to go ahead and start this up. And you'll notice we get a couple errors. It's like, hey, scroll too fast. Hey, I don't see that service group yet. I don't see that service group yet. Oh, there we go. I found it because the ring has completed. I've propagated that gossip membership. And there we go. Nginx is now running. And it started the process. And you'll notice that it compiled nginx.conf and mime.types. Those are the configs that are being managed by this Habitat supervisor. So now the moment of truth is if I open, we'll do side by side here. If I open another tab over here and I curl localhost, boom, not only am I hitting the load balancer, because you can see the log message here on the left, but if we run this a couple times, tpn 0.5 curl -s localhost, what this is doing is every half a second, it's running that curl command, and you'll notice that we're hitting different IP addresses, 3, 4, 5, they're running on different nodes. So these are actually behind a load balancer, all monitored by Habitat, and all the backend upstream dynamic load balancing, all of that was handled by Nginx, based off of the Habitat integration. Pretty cool, right? Y'all are scaring me. All right, fine. I can see you're not impressed, so let's change that. I'm going to close this here. I'm going to jump back over to my studio. So the studio is still running. But this studio isn't connected to that peer group at all. The studio is running its own supervisor, but it's not connected to those Docker containers that are running. So what I'm going to do is over here, I'm going to run that same curl command as before. So same thing that's happening. But I want to push out a config change. So I want to have config apply with HTTP echo.default. I want to give it a monotonically increasing integer, so this time it's going to be that. The text is going to be hello world, but I need to somehow target these other peers, and I do that by passing in the -- peer flag up here. And I can give, again, any one of those peer addresses. So in this case, I'm going to give .0.4, and I can't type. Text equal, I need an ending quote. There we go. So that config applied, and now it's updated, just like that. So now it says hello world. And I can come over here, and I can say that the text is banana. And the text will update to a misspelled banana. Is this cool stuff now? All right. So the challenge I have now is that I don't know about you, but I don't run prod on my local laptop, at least not anymore. So let's go ahead and quit this. So I'm gonna exit the studio. We'll quit these Docker containers. No, we got time for that. And we'll quit the Nginx here. OK, so now we're back to straight up production. So we're going to go up to our production. And nothing has changed about the Habitat package. I haven't added anything or changed anything, so it's the same dynamic one as before. What I've added into the mix now are 3 new tools. HashiCorp Terraform, HashiCorp Console, and HashiCorp Nomad. Sorry, we have so many tools. All of these tools are free and open source, and they integrate really well with the product, as I'm about to show you. So the first thing I did in advance was I spun up a cluster. So inside this repo, which again will be open source, I have a bunch of Terraform configurations. Terraform is an open source tool for provisioning infrastructure resources. Amazon, Google, Azure, DigitalOcean. It can manage not only just compute instances, but it can also manage things like GitHub Teams and permissions, or integration with your Oracle public cloud. Basically anything that has an API in a declarative syntax. So I have a bunch of Terraform configs in here. Not trying to teach you Terraform here. What I'm trying to show you is that this whole cluster provisions in about 3 minutes, but I wasn't sure how long my talk would take, so I did it in advance. So what this is doing is making sure I'm all up to date. And what I have here are 5 R3 XLs running as clients and 3 C3 2XLs running as servers. Not important if you don't know what those are. Beefy instances that can run lots and lots of applications running in Amazon Web Services. This demo has nothing to do with AWS. You could run this anywhere, but just for illustration purposes, that's what I'm using. These clients have software pre-installed. Particularly, they have 2 HashiCorp tools, Nomad, which is an application scheduler, and Console, which is a service discovery and distributed key value store. Nomad is akin to something like Mesos or Kubernetes, if you're familiar with that terminology. And then Console's similar to something like Zookeeper or other service discovery frameworks. It provides a registry, and that's important. And I'll talk about why in a second. So what I'm going to do right now is I'm just going to jump on one of these clients here. So we will log in here. Oh, look at that. You get a nice have a great day, MOTD, configured that. All right. So one of the interesting things about schedulers is the way most schedulers work is they run multiple applications on the same physical host. But if you have applications that bind to a specific port, in this case 5678, you either have to use like overlay networking and then do some type of firewall routing, or you can do what's called port mapping, where you use really high port allocation numbers, like 43,570 or 67,123, to dynamically allocate these resources on different ports. Then you have some type of registry that keeps track of what ports these services are running on. You'll also recall that in the previous sections, in order to join those things together, those 3 HTTP echo instances and that 1 Nginx load balancer, I had to copy and paste an IP address around. That's not really automation friendly. And I want to be able to scale this very rapidly. Again, we're the next MySpace. We have to be able to hit that maximum scale. You guys are joking. You think I'm joking, but it's for real. So in order to fix or alleviate this problem, I'm leveraging Console. What Console is going to allow me to do is I'm going to start a service. I'm going to register that service with Console. Particularly, that service registers itself with Console. Console then knows its IP address, the ports it's listening on, a bunch of metadata about it, and then I can query Console's DNS interface. So I don't have to pass around IP addresses. I can pass around well-known DNS entries. And let me show you what I mean. Jobs. OK. So this is a Nomad job. I haven't told you a lot about Nomad yet, but that's OK. We'll talk about it in a second. This is a Nomad job specification. What I'm doing here is I'm starting a service. You can see that's type equals service with a priority of 80, which is just an arbitrary priority related to the other jobs that are running. I'm running it inside Docker, and I'm running the official Habitat HAB management supervisor. And I'm marking it as a permanent peer, which means this helps protect against like network partitions and transient peers. Again, Habitat implementation detail. The important part here are these 4 lines of code. I'm registering this service as hab-sup, so that name equals hab-sup, and I'm saying that it has an HTTP port. That's not actually port 80, as you'll see in a second. It just has an HTTP port. What this says is that this service will be available at hab-sup.service.console. Just like .myspace.com, .service.console is a TLD that Console resolves within your data center. I'm specifying the resources that I need. So I need 1 CPU and 1 gig of RAM, which is a little bit of overkill, but whatever. I need 20 megabits of network And I'm allocating a static HTTP port 9631. That's the port that Habitat runs its HTTP server on, and a static port 9638, which is the port that the Gossip protocol works on. So pretty easy. This is basically encapsulating the Docker run command into a text file. And the advantage of doing that is like now we get code review, we get peer review, we can version this text file, and we can very easily check it in and out of source control. For now, I'm just going to go ahead and run this. And I do that via the Nomad run command. And I pass it in the path to that. And what this does is this triggers what's called an evaluation and an allocation. So it inspects the cluster. So Nomad looks at your cluster as like 1 terabyte of RAM and 1 petabyte of disk space. And it does bin packing to schedule the application in the most appropriate place on the host. We don't really care where it went. It might have gone on this host that I'm on. We can check and see. Did it? It did not. It's not running on this host. It's running on one of the other clients in this cluster. It doesn't matter. But then how do we find it? We don't know its IP address. Well, that's where console comes in. Because what I can do is I can hit habsup.service.console, and that will resolve to the IP address that this is running on. But what's nice is unlike copying and pasting this IP address around, I can hard code habsup.service.console because that's actually a dynamically resolved endpoint. So that means when I peer, when I pass in that -- peer flag, instead of 1.2.3.4, I just pass in habsup.service.console, and we rely on the kernel to resolve that. The resolution actually happens to console, which exposes itself in a DNS-like interface, and it resolves to the service discovery layer. So let's check out what that looks like. So let's look at another job here, the HTTP echo server. So this is going to look very similar. I'm creating a service. I'm creating 3 of them this time. So I only have 1 supervisor, but I have 3 instances of this server. So again, very similar to what I ran locally a minute ago. I'm giving it a really tiny ephemeral disk because my service doesn't actually need a disk at all. It's just for logs. That's the only thing I need disk space for. I'm starting it as a server, and then here's where things get a little bit different than what you might have seen before. I'm passing in this environment variable, hab HTTP echo, which is the environment variable that Habitat looks for its configuration. And the port that I'm giving the service to listen on is Nomad port HTTP. Nomad, at runtime, dynamically populates the values between those curly braces with a really high numbered port that it's allocated for this task. So that means my server, instead of running on 5678 like it has been, it's going to run on 23,406, or whatever available port is decided. And the scheduler does that for us. We don't have to think about it. Down here, I'm passing in some arguments to my container. Remember, my container is running the Habitat supervisor, and the Habitat supervisor, by default, runs its HTTP port and Gossip ports on 9631 and 9638. But if I build those ports on my host, that means I can't scale my application. There's only 1 port that is 9631. I can only bind that 1 time per host. So what we do here is we actually allow Nomad to dynamically assign not only the port that my service listens on, but the port that Habitat listens and gossips on. And each instance of our HTTP echo application will be assigned a different dynamic high port number. And Habitat handles this seamlessly. Since this is a tiny little Go binary, we can actually give it very minimal resources. Here, it's getting 1/20th of a CPU, 128 megs of RAM, which almost all of that is just for Docker, 5 megabits of memory, and I'm allocating 3 dynamic ports. And you'll notice they're dynamic because there's nothing inside of them. What that's telling Nomad is just pick me a port that's available that isn't privileged. So like not 80, not 443, something like less than, say 1,000 or higher than 1,000 that I can bind to very easily. And I think that's it. Oh, and then I'm telling it to do minimal logging so that I can keep the disk space low. And I'll show you why in a minute. So let me go ahead and run this now. So I'm going to run the HTTP echo job. It's running. It was that easy. Let's jump back. When we run the Nomad status command, we can see we have 2 jobs or 2 services running, hab and HTTP echo. We can get more information about a particular service by passing in its name. So here I can ask for the status of hab in particular. We can see we have 1 running, and it has an allocation. Each instance of the application or service will have an allocation. So I can get the status of this allocation. And here I can see that this particular habitat supervisor is using 2 of its 1,000 megahertz of CPU, 66 of its gig of memory, 30 megabits of disk, and it's bound to 2 addresses, the 10.1.1.26 and the 2 different ports there. And we can actually get the logs for this service as well. So instead of Alex status, we can ask for the logs. And that log output should look really familiar. That's what we saw in the studio and what we saw in the Docker container. So we can verify this thing is running. Same thing is true for HTTP echo. So we can ask for the status of HTTP echo. And you'll notice that I didn't fill the whole thing in. It's a quick greedy match. We have 3 of these running. They've all terminated to the running status. I'll just grab the first one here. I'll check the Alex status. And here's where things are going to look a little bit different. Notice that the HTTP port is 56,876. I'm running on a really high gossip port and a really high have HTTP port. And these were ports that the scheduler assigned to me. And notice that it's a different IP address. This is running on 2.175. I can also get the logs for this service the same way we did before. And we can see it's running. And I can grab this IP, and I can curl that IP, and we get a thing. So it's actually running. Like, it's not BS. The thing is actually running. That's a different host in the cluster, and I just hit it via curl. And there's 3 of these running. So just like before, I need to put these in a load balancer, because I don't want to copy and paste IP addresses around. So we'll take a look at the Nginx load balancer job. Again, it's pulling down the same Docker container, but the one difference here is on line 3, the type is no longer service. The type is now system. This is a special type of job in Nomad that instead of specifying a count, this tells Nomad to make sure that one of these is running on every host in the cluster. And as new hosts join, they automatically get this. And I'm binding this to port 80 on the cluster. So again, dynamic port allocations. The important part is down here, I'm binding on port 80. So what that means is every host in my cluster, in this case, every AWS instance, is going to have an Nginx service listening on port 80 bound to the host, which means if you hit the public IP of this AWS instance, you would be hitting this Nginx load balancer. This is important in a second. For now, I'm going to run this. I have 5 clients. How many Nginx servers are going to get scheduled? 5. Let's see if we're right. I hope we're right. It'd be awkward. 1, 2, 3, 4, 5, right? We got 5 scheduled. And Nomad's handling like the downloading of this container. It didn't exist in advance. It's handling all of that background network traffic and placement. It's making sure that there's one of these on every host, every client in the cluster. So we can check the status of the Nginx. Perfect. All 5 of them are running. And if I run Docker PS, you can see, oh, look, that's one of the Nginx containers. And I can Nomad status Nginx. I can grab one of these allocations, and I can ask for the logs of this allocation, and we can see that it's actually getting requests. And oops, I'm giving something away here. There's an ELB health checker coming in, which I'll show you in a second, but those are the logs. So now what I can do is I can curl localhost, because this thing runs on localhost. It runs on localhost port 80, but it also runs on localhost. And L-O-C-A-L host. It runs on localhost, and each time I hit this, I'm getting round robin to a different thing. So watch-tp and 0.5 curl -s localhost. OK. And you can see that that's changing continuously. But like I said before, we need scale, right? So how many of these do you think we can reasonably run? How many people think we could hit 50? 50? All right, let's check it out. So one of the differences between Nomad and other schedulers on the market is its speed. So with Nomad, we scheduled 1 million containers in under 5 minutes. So I'm about to schedule 50, so this should be pretty darn impressive. So I'm going to time this, Nomad run jobs HTTP echo. And I didn't Nomad, there we go, Nomad run. And it's going to do the evaluation, and that took a little bit over a second. So we just scheduled 50. We scheduled 47 containers, because there were already 3 running. And what's interesting is that these are actually public-facing. So I'm going to jump over to my laptop here, and I'm going to fire up a web browser. And I'm going to hit nomad.hashicorp.rocks. You can hit this on your phone if you'd like. This is a real URL that is actually load balancing all those clients, and I'm just hitting refresh. So all 50 of those clients are being load balanced. You're free to try this out if you'd like. This is a public-facing thing. So what we have is there's a load balancer, an Amazon load balancer, an ALB, that is hitting port 80 on all of our clients, and port 80 is listening to Nginx, and Nginx is routing traffic to these dynamically bound backend services. They're dynamically bound and registered with the Habitat supervisor. I have 2 seconds, but I'm just going to keep going. Y'all are free to leave, but I have one more thing to show you. So how many people think we can do 250? All right, so let's check it out. So we'll time this. Nomad run. Jobs, HTTP echo. How long do people think this is going to take? 5 seconds. Let's check it out. Remember, we're only scheduling 200. It took 1.14 seconds to schedule 200 containers. So we have now reached critical MySpace mass. And if we jump over here, we'll start seeing more and more and more of these instances running. And I don't have time for it, but the end of my demo was pushing out a config change that said thank you, but I only have -44 seconds left. So that's the end of my talk. Everything will be public on GitHub. I'll tweet out the link. I'm Seth Vargo. Thank you. Bye.